There are two categories of types in Swift: value type and reference type. In value type, each instance keeps its own unique copy of its data. Each time when the type is initialized, assigned or passed as an argument, it creates an independent instance with its own unique copy of its data. And in reference type, each instance shares a single copy of the data. So each time when the type is assigned or passed as an argument, it refers to the single instance of the data. And it means that it refers to the same memory address in a heap. Let's consider an example. We only have reference object 1, which is reference type, with this address, and actually create an object 2 and assign object 1 to the object 2. And as you can see that object 1 will have the same address as object 1. Object 2 will have the same address as object 1 because they both of them are reference types and they're sharing this same memory, same single instance and pointing to the same memory address in a heap. Value types are stored in stack and reference types are stored in heap. So let's consider an example. Let's create a struct which is value type with property name fruit, and let's create our first instance of the fruit, and it will be orange. Let's create another instance and assign it orange to it. So the pineapple now equals to orange, and let's print the name of this fruit. Pineapple name. So both of them had orange as name, and it's 21 hours. Set proper name to pineapple. It's proper emoji name, and as you can see, orange has an orange emoji and pineapple has its own emoji. And how struct works, the concept based on that when you created the fruit instance, it will be an independent instance with the property name, and when we actually assign a pineapple to the orange, we have an orange instance, and pineapple, when assigned to pineapple, will have copy of orange, and it will be an independent instance, and it will copy all of those data in this instance. For example, the data is now name of the fruit, so name of the fruit will be copied, and we actually when changing the name of this instance, we're actually not changing the original instance, but we're changing the copy, so original is not affected. And this is for value type. In the reference type, concepts is different. So let's create a class which is reference type food and give it name, and create an initializer name, and let's create our first instance. Okay, let be sandwich, and it will be food with the name of sandwich. And let's create another instance pizza and assign sandwich to the pizza, and let's print names of this instance. Pizza name. Zara name. Let's run, and actually we can now comment it out for now. And you can see that sandwich has a name sandwich and pizza has name sandwich, and everything is fine because actually the pizza is now equal to the sandwich. And what will happen if we actually want to set proper name to the pizza? It's proper emoji, and let's run. Now both pizza instance and sandwich instance has a name of pizza, and that's how reference type works. Why it's so? The reason is that this when we created the sandwich, it created the instance of the food, and we assign the sandwich to the pizza. We're not making the copy, but actually we're passing the reference to this to the original instance, which is in this case is sandwich. So when we change the name of the pizza, it automatically changes the name of the sandwich. So let's see more deeply, and let's pizza and identifier sandwich. Okay, let's actually reward them and print. Let's run. As you can see, this one, okay, sandwich. As you can see, the address of the both instances are the same, so they're actually referring to the same memory address in the heap. So if we will change one of the instances, the other instance will be affected too. So let's now sandwich name of the sandwich is changed. So let's change sandwich name to croissant and print them again. Now both of them will be croissants because we changed the shared instance, and now they have the same name. The same thing happens when we pass this when we pass the reference type and value types. When we pass the value types to the function, it will pass the copy, and when we pass the reference type, it will pass the reference to the address in the memory. So let's see. Let's delete this one. Let's delete this instance also. Let's create a function change name. It will get an food change fruit. It will take fruit and try to change the name of the food. For example, let's make it watermelon. Yeah, when passing the argument, we actually passing the constant. So you need to create new instance. Let's call it new fruit. It will be fruit, and we will change the name of the new fruit. And let's create orange. No. Let's create apple. And print apple name, and then call this change fruit function and print the name of apple again. Right, so the name will not be changed, because when you pass in the fruit, we're actually passing the copy. So this is what is one copy, and this change will not affect our original instance. And let's see what will happen with the class instance, with reference types. And let's create another function, change foot, so new foot will be foot, and new foot name will be croissant. So let's create our pizza instance. Okay. And pizza instance, and then print name of pizza. Let's call change food function with pizza, passing the pizza, and let's print name of the pizza again. Let's run, and as you can see, and when we created the instance pizza, the name was correct, pizza, and when we pass this pizza instance as an argument to change food function, the name changed to the croissant. The reason is that when you pass in the argument to the change food function, we're not passing the copy of the instance, but actually passing the address to this instance in a memory. So how can we see that? Let's print its memory address, and let's call this function inside the change food with new food. As you can see, they have the same memory address. So you can use the value type. So if you, in the multi-threading, when you want, when you want to make sure that the state will not be changed across the multiple threads, and you can use the reference type when you want shared instance. So maybe when you want to change make a change instance one in one of the threads, and so if in the multi-threading you can use value types, and if you if you don't want to share the state of the instance, you can use reference types. So that's value type and reference type. Thanks for watching.